All right, Sue, we're recording, so why don't you go ahead.
Okay. Hey, everybody. Welcome to our continuing CCC 2015 rebroadcast. One of our guest speakers, who speaks a lot at our different conferences, is with us today, Mr. Clyde McPherson. Clyde's going to be covering a topic that's near and dear to his heart, which is high availability of CA Datacom, or the ability to run 24/365. Clyde is a senior, experienced Datacom person. I use the word senior as meaning an age, not necessarily a skill. No, I won't say that. Clyde is one of our favorites. He's also one of our most important validation clients for the Datacom software. And with that, Clyde, take it away.
Okay, we can still hear me?
We can.
Good. Okay, hi guys, hi people. As Kevin said, first of all, thanks Kevin, and thanks everybody who helped set this up. As Kevin says, I've been working with Datacom for a long, long time, and with the improvements in the software over the years and the greater requirements of the site, 24/7 has become more and more important each year. So now I'm going to try and step through the slides. Yeah, good. Okay, so a brief abstract there, nothing, no big deal. Here's the high level of what we're going to talk about today, why we need 24/7, what 24/7 involves to us, high availability of the multi-user environment itself, data availability, not much good having the mup up before your data is unavailable, data access, getting to your data from different application points, and what is in the futures for us, and this includes basically Database 15, which while it's now GA, we haven't got there yet at our site, so it's future for us. So we'll start. Why is it a requirement? Well, I guess all of you know this by now. More and more applications need to be 24/7 as they come online. They're designed with 24/7 availability in mind. Business is less tolerant of either scheduled or unscheduled outages, and in most cases these days, the scheduled outages are the greater hit upon us because the software and the hardware is much more reliable than it used to be. So even for applications that haven't changed or are not new, the business itself just wants more availability, just as a matter of course. And so following on from the data idea, there's a business need to limit data maintenance impacts. If you have to have databases down for unloads, reloads, reorganizations, adding new keys, stuff like that, then that's an outage to the application or to multiple applications. So we've got to reduce the number of reorganizations we need to do, and we need to reduce the time it takes to do them. Data structure modifications I touch upon there. Performance of data access must be maintained, so whatever you do, the database still has to be fast and reliable. And the data must be available to as many application sources as possible. Companies want to develop their applications on multiple platforms these days, looking at the web in particular. So first, the high availability of the environment itself, and one of my favorite subjects is the shadow muff. In this day and age, in the ZOS site, it is not clear to me why anyone would not have a shadow muff on their high availability multi-user environment. It can be a very cheap option. You can make it more sophisticated if you like, but it can be a very cheap option for very quick multi-user re-availability. It will allow for an unscheduled muff outage in the simplest form, or in a more complicated form, even an unscheduled LPARS outage. And the internal software provides seamless switching of the Datacom workload. You can anticipate maintenance or anticipate scheduled outages by moving the database environment to a different multi-user using the shadow muff. We'll talk more about that later on. There is absolutely no performance impact on having a shadow muff active. It just sits there using no cycles and just waiting for the opportunity to shine. The failover and migration capabilities were significantly enhanced in Datacom CITS Services Release 11 and are even better in V14. And by that I mean that when the multi-user so I should phrase that as if, Kevin, sorry, if the multi-user fails and migrates over to a shadow, then the CICS regions will dynamically reconnect to the new multi-user. No site interference is required, and we'll see an example of how that works later on. So the capacities that make this possible are the multi-MUF support in CICS services, the ability to connect to more than one multi-user, the disconnect and reconnect capability at the multi-user level, and the dynamic or immediate disconnect capability, which provides instantaneous reconnect. You'll see that in the example. So here's a simple architecture of a shadow MUF, and we employ this in two of our major multi-user environments. The shadow MUF is on the same LPAR as the multi-user. And really, this is provided for the application that really only runs on one LPAR. If you have an application where all the CICSs connected to it and all the batch jobs connected to it run on the same LPAR as a multi-user, there's not much point in having LPAR failure capability on that system, because if the LPAR comes down, you're going to have to restart all the applications anyway, so you're restarting them up while you're doing that. So there's not really any point in running that shadow on a separate LPAR. For this environment, you don't need coupling facility space, so that's the expensive resource you might be afraid of with shadow MUF, but for this sort of failure capability, you don't need coupling facility space. And it does support having a CICS region on another LPAR. You can see we have a CICS flex here where the CICS regions are actually on different LPARs. That is supported. That's not a probability. It just means that if the LPAR fails, the multi-user is not going to come up automatically on LPAR 2. You have to do that manually. And one bullet I added here, instrumental in V14 to V15 outage-free upgrade. For those of you who looked at V15, the upgrade can be managed without an outage of the multi-user, and the shadow MUF is instrumental in making that happen. So you might even want to look at just putting a shadow MUF in for the upgrade and then taking it out afterwards if you're really so motivated. So here's a more complicated architecture, and this might be for a system where you genuinely have applications on both LPARs. So in here you see two CICS plexes, and what I'm saying in this application is that the CICSs on LPAR 2 maintain the entire application environment even if LPAR 1 has gone away. So in this case, it makes more sense to have the shadow MUF on LPAR 2. So if you lose the primary MUF, it fails over to the shadow on LPAR 2. If you use the entire LPAR, it fails over to the shadow on LPAR 2. And since the applications reside on LPAR 2, you have continuous application processing. The second bullet here adds IPL toleration if the coupling facility space is defined. Once again, you don't need coupling facility space, but if you want to use this architecture for what we call a migration as opposed to a failover, you will need coupling facility space, and we'll see how that works. We have this application, this architecture in our most critical 24/7 multi-user environment. So here's just an example, JESLog, or yeah, I guess it's JESLog, of a multi-user failover. So the first box at the top is the active multi-user running away quite happily, and suddenly it fails. So you get informational messages thrown out saying where termination is complete for the remote MUF, termination is complete for the local MUF, the multi-user abends. Note the time of the failure. 14:54:23, 14:54:26, we could restart the MUF on a remote LPAR. 14:54:50, we could restart it on a local LPAR. Coincidental with that last item, 14:54:50, the second box shows that the local shadow MUF actually starts to initiate, starts to enable. No application requirement required, no application involvement required, no user involvement required. It starts to do its enable, connects to the coupling, connects to the MUF with the XCS. It does its restart, so it's a sort of a pseudo restart it's doing to resynchronize all the buffers, and then it enables. So in that time frame, 2 minutes and 6 seconds, without any intervention, your multi-user is now enabled re-enabled on that LPAR after the failure. That's often, in our case, even before the computer room realizes the muff has gone away. And here's a short example of what will be happening in a CICS region that is connected. At 14:54:20, the region realizes the multi-user has upended, so it does its immediate disconnect, and that involves a cleanup of the control blocks connecting to that muff. And then, as applications continue to process, as transactions continue to run, it attempts to reconnect to the multi-user. At 14:56:56, the multi-user became enabled, you saw on the previous slide, and at this point, the next attempt to reconnect is actually successful. So you see the DC00185I message there. Multi-user is now connected. It goes through a restart, so it restarts all the URTs that were open at the time of the failure. And so in a time of 2 minutes and 36 seconds from the original failure, your CICS is now reconnected, and application processing is continuing in that region. So for a total of less than 3 minutes, we've failed over to our standby system after a multi-user failure. As I said, I can't see why people would not be using this, the shadow muff, at least in this limited capacity on all their major production environments. So here's some pictures showing how we use the remote LPAR shadow muff for IPL avoidance. So here we have our environment running on LPAR1, a multi-user, a CICS, an MQ data sharing environment on the 2 LPARs, and a shadow muff on the second LPAR with some more CICS regions, and we have coupling facility space defined in this case. The manual is pretty clear on how to define coupling facility space and how to calculate how much you need. So we start, we have an IPL scheduled for LPAR1. So we start by issuing the migrate to shadow command, which can go to either multi-user, and that enables the shadow muff and creates the muffplex. It creates a data sharing environment between the 2 multi-users. Now obviously this is, well, obviously not the right question. This may well be an environment you don't wish to run in for too long because it's not a high-performing situation, but a temporary muffplex is created while the migration takes place. Another important component of the migrate to shadow is once the shadow is enabled, then the active muff automatically goes to EOJ status. You do not need to issue a manual EOJ. That is automatic. Now it's not coming down because everything is still connected to it, but it's now an EOJ status. So then we start the partner CICS for the CICS specs on LPAR2, and that automatically connects to the muff on LPAR2. So now we've got application continuity across the CICS regions. We then disconnect the CICSs on LPAR1. We disconnect the 4 MMF CICS regions on LPAR2, and at that stage, we still have applications running in the CICS on LPAR2. At that stage, MUF1 goes away, and LPAR1 is available for IPL. Now the application, you reconnect the MMF CICS regions to the MUF on LPAR2, and now you have your full application environment running on LPAR2 while LPAR1 is being IPL. Essentially an outage-free migration of the multi-user to the second LPAR, applications continuing. We've been using this 24/7 system, I don't know, for probably 4 or 5 years, I guess, with outages every 8 weeks as we IPL the LPAR1. We happen to migrate it back at the end of the process because we want it to run on LPAR1 most of the time. But if your architecture is such that you can leave it on LPAR2, then you can leave it there till the next time you have to IPL that. Okay, so quickly through some startup options that relate to high availability. The log pend option we're all familiar with. It controls pipeline efficiency, so the higher the number, the better it is for your efficiency of the multi-user, but the higher it is, the impact it has on restart and failover time, since failover is basically a restart. But with more efficient restarts in the current releases, you can go for higher log pen values than you had before and improve your multi-user efficiency. The muffplex card is the option you require for the shadow muff or for the muffplex if you're going to use that. Restart, various options on restart control what you do if the restart get errors. If it's more important to you that a restart error causes the muff not to come up, then allow that to happen. If it's more important to you that the muff be allowed to come up while you manually address the individual issues, then you can specify that as well. Ignore errors, turn base access off, things like that. SVC dump, yes or no? SVC dump is a much, much quicker way of getting a dump of the multi-user ABINs. Highly recommended. I think the CICS support team prefer it as well now for their diagnostics. The XDump number blocks parameter gives the multi-user an idea of how many of the most recently used buffers it should take in a buffer PXX dump to try and limit the time it takes to take the PXX dump. So you run the risk maybe of losing a buffer that was important for diagnostics, but the quicker PXX dumps are very important for the ongoing availability of the multi-user. The simplify option in version 14 is miscellaneous features. It's not really high availability, but in the sense that if you point your multi-user at the wrong CXX or point your multi-user at the wrong data set, you're probably going to have a major outage. It is high availability in that respect. New copy command, or we swear by now, enable a way of applying most fixes to the multi-user without having to bounce it. You can just apply the fix to the module in the appropriate load library and you copy the module to basically replace it in the multi-user. You get the fix applied without an outage, and this is applicable for most solutions. There's a reasonably recent URT and CBT option, a DBC CBT option, EOJ-OK, which basically says that if you issue a muff EOJ and any of these URTs or CBTs are active, then they will be gracefully disconnected from the multi-user without you having to go and do it by hand, so that enables you to bring the multi-user down more quickly, and if you bring it down more quickly, then presumably you can bring it up more quickly. So it is limiting outage time. The XCF_from parameter, this is the version 14 startup format, and version 14 is also a console command, so you can actually control your XCF availability, XCF connectivity dynamically with the multi-user up, which gives you more flexibility in that area, and again may save you an outage if you have to dynamically add more XCF capability. Now we'll move on to data availability. We are big users of the defrag utility. I think it came out with at least 12. And basically what it is an outage-free cleanup of an index. It doesn't rebuild the index from scratch, but it does go ahead and defrag. You know, over a period of time, a dynamic index can become fragmented, very empty blocks, completely deleted blocks, split blocks all over the place. So this process goes through and defrags the index. And it can run for a while, but it's running with the multi-user up with the index available, so it's not impacting anyone. Basically, it's just another index-intensive application running on your multi-user. And a bonus is that it could reduce the number of levels in the index, which is going to improve your performance of the index. That's a little bonus you can find. Now, our defrag strategy, summarized in a few bullets, is based on the space utilization of an index. How much space do we have left? I mean, if it's 99% full, we may try a defrag to see if we can reclaim some space without having to do a dynamic extend or wait on a dynamic extend. And it's based on the historical information of how much space reclamation we've had from previous executions. If the index is just being added to and not deleted, then you're not gaining much space. So there's not much to defrag, so there's no reason to do it. At the moment, we really don't have a good history of performance improvements. We don't regard defrag as a performance option. We regard it more as a space option. And as I hinted at before, we have no hesitation in running defrags during any shift. At any given time in any of our multi-users, there's a good chance that there's going to be at least one defrag running. Some of them run for several days, but again, it's non-impact, it's restartable, it's not impactful, so it just runs as long as it needs to run. Here's some simple examples. The numbers on the left-hand side of the spreadsheet are from the cut and pasted from the actual output of the report. You see on this first base here, base 66, the defrag ran for 3 days, we gained only 7%. The next one ran for just over an hour, and we gained 33% back in space, from 98% full to 65% full. 13% gain on the first one, and then a couple of examples of repeated occurrences. A couple of quick defrags on base 116. The first one gave us 41%, and the second one still gave us 35%. These are examples of some of the space savings you might realize from running defrags. The partner for the defrag is the online reorg process, and what you have to bear in mind here is this is designed to make data more sequential access friendly. If you're not accessing a given table using sequential processing, there's not a lot of point in doing this. This is designed to make your sequential processing more quick. If you're just doing randomly, then this is not going to be a great deal of use for you. So our strategy means we're targeting tables showing on how sequentially active they are reported by the history ADS table. We run that report regularly, and our DBAs keep track of which are our most sequential tables. And the other factor is how is the sequential efficiency as reported by the data NE report, and I'll give you an example of that later. If it's already very efficient, then there's no point to run the report. But if it's a lot sequentially active and it's not very efficient right now, then the OLREORG is what you need. Again, it runs with the database open for applications. In version 14, it may be fixed and it may be back level to version 12, I don't know about that. There was a new space reclamation option, or some new space reclamation options added, which exploit the OLREORG even better, because so the limitation in the first implementation was that if you didn't have a lot of free space in your area, then you weren't going to get a lot of data blocks or data rows moved around to get full efficiency. With the new space reclamation options, you do get the benefit of that, and we'll see how that works in a minute. And those changes, the space reclamation changes, can be made very simply. It's just a simple dictionary and CXX change. The ref group equals 0 is the option used in the online reorg to get maximum sequential efficiency, but it also makes the online reorg run very slow, so we only use that on our smaller tables. We get better bang for the buck overall by using slightly larger numbers on ref group. And then there's the first key, last key option, which we use in some occasions to target our online reorg at a certain part of the table. If only part of the table is being accessed on a recurring basis and most of the table is historical, then you're not gaining anything by powering through all the CPU cycles required to reorganize that or to reorg that unused part. So you can focus your online reorg on the preferred part of the area table. So here's some numbers here, database IDs, time. DSOP4 is the new reclamation equivalent of data space option 1, which is the old random reclamation. So DSOP4 is random reclamation with online reorg enhancements. You can see the ref groups, 2 in most cases, 0 in another. And the report tells you how many rows processed, how many rows it moved, and how many blocks it freed. So you can see the first one freed up 133,000 blocks, and it moved about 7.5% of the rows. And below that is a cut and paste from the data NE efficiency report. So you can see going in for the first table, I don't have the database's ID because this is just to show you what you can gain. Going in, we had an efficiency of 49%, and afterwards we had an efficiency of 73%, 65% to 85%. On the last one, we went up from 71% to 100% efficiency. So this may have saved us an outage in some of these tables to unload and reload, reorganize in the traditional manner, because we were able to do the online reorg process. Data NE report, I built an example, efficiency of the data area, confirm the need for reorganization, and to report on it. Here's a little enhancement that was available in version 14. You can actually use the report to generate online reorg cards. So by adding these parameters that are in red, you're telling it that we want to we want an online reorg generator that will aspire to 50% efficiency. We want to generate the parameter cards in a DD name called OLREORG, and we want to generate the online reorg with a ref proof of 0. So out of that, in that OLREORG DD, we get this set of parameters: online reorganization on the appropriate table and database, ref proof 0, and it's generated the first and last key. Actually, I misled you. That percent number is saying target the areas that are less, or target the section of the base that's less than 50% efficient currently. So what this has done now is it's given us a key range, first key, last key, saying that the data rows within that range are less than 50% efficient, so we're going to target our online reorg to that area of the table. So now we can just take those parameters and feed them into an online reorg utility, and we'll get the targeted reorganization we want. Miscellaneous features on data efficiency, data availability. The QUIESCE command, again, this is another no-brainer to me. This is how we take our nightly backups. We have DASD, shadow DASD, at just after midnight at a time of low activity. We issue the QUIESCE command, and while the multi-users quiesce, the commands are issued to split our DASD. We then issue a spill to synchronize the recovery tape up with the split DASD. Then we issue the QUIESCE off, and now multi-users back and running again for the cost of a 2-minute pause or so, and now we can back up the split copy of the DASD to get a clean backup, a clean and stable backup, because the QUIESCE command flushes the buffers as it goes into QUIESCE status. So the data and index on our split copies are consistent and suitable for restoring if we need to. There are two options on the QUIESCE, the transaction or request level. The transaction level says maintain or do not go into QUIESCE status until all transactions come to a transaction boundary. And on a very busy system, that can be quite a long time. You might have a long-running transaction. So all your other transactions have QUIESCE, so everything else is not working except one silly batch job, which is continuing to run, and your system is effectively down. So we can't afford that on our major system. So we use a request level, which is not quite as stable because it's stopping the multi-user at the end of each next request, not a transaction boundary, but it makes for a very fast QUIESCE. Both of those QUIESCE levels, by the way, will reset the log sequence number if it's over OS 1 billion. If it's over the value that's considered risky, it will be reset. And so will a QUIESCE RST, which does nothing else apart from reset the log sequence number. So that's a side bonus of this command. If your multi-user is up for a long, long time and your log sequence number is getting high, a QUIESCE command will reset it and avoid any implications of that. Another feature is multi-use =yes utilities. Hopefully we're all using those by now. The ability to mix utilities and application activities on different areas of the same base. You need to rebuild the index for one area. You can do that while the other areas are still available. You have the potential, even if the database is entirely down, you can speed up your utility window by running parallel multi-use utilities side by side instead of running them serially one after the other. We have a little application that requires use of the any parent, where we have a database that's partitioned into 12 months. And in month number 1, we want to clear out partition 12 from the previous year and null load it. Sorry, we want to clear out partition 2 from the previous year and null load it so it's ready for next month. Using the any parent and multi-use yes utilities, we can take that one partition offline, back it up, and null load it, while partition 1, the current one being used, is still available to the applications. So we keep our rolling partitions available over a 12-month period without any outage to the application. And that's made possible by the multi-use QUIESCE utility and the any parent. Directed dynamic extend is another tool that's being enhanced from release to release. I consider dynamic extend one of those examples of, well, yeah, this is what we wanted, but now we want more. Because when dynamic extend first came out, it was the bee's knees. We could suddenly get our databases extended dynamically when they filled, and we didn't have to have an outage to manually extend them. We didn't have to have a predictive outage to manually extend them, and that was great. But then the dynamic extend was taking 8 minutes on some of the full volume data sets, and while this is great, it's not really great. So in release 12, we had the directed dynamic extend, where you can now anticipate the extend be needed and just issue a console command to the multi-user that will extend the database for you. There's no outage, no interruption in service, and the extra space is available to be used immediately. So in 14, as well as index or data sets, 14 added the CXX, so no outage now to completely unload and reload the CXX when it unfortunately fills up, which doesn't happen very often, but when it does, it's a pain in the butt. And in release 15, you can dynamically extend the LXX. There's special rules apply, but again, the same things apply. If you suddenly find your LXX is too small and wrapping too often, or filling and force committing too often, you can dynamically extend that without an outage. Also in 15, I think it's 15 or maybe 14, I can't remember, there's the ability to dynamically extend a virtual data set, a virtual database. So if you have a virtual database like base 6 or base 17, in the past, if that filled up, you were doomed, but now in 15, you can dynamically extend those as well. So the dynamic extend, as the last bullet says, will use either your default installation default value, whether that's the DD dictionary value or the secondary allocation value, whatever your default is, it will use that, or you can override it. If you've got the need for a special one-time extend with a special size, you can override the value, and that's what I have in the second example here. I'm overriding whatever is set for this index to use 10 cylinders on this occasion. Forward recovery to span a reorganization of the target base if you need to. And we could see that as a way of emulating what we call our roll forward process, which we talk about a bit later on. But you could see how you could now get a database to another system, reorganize it, and roll forward the recovery tape, spanning that reorganization using this option. Multi-data set indices, another new feature was 14. Potential performance improvement.
Hey, Clyde, I'm sorry to interrupt you, but it sounds like the sound just cut out, or you're very quiet now. I don't know if you changed something on your phone or not.
I didn't. Can you hear me still?
Yes. Yeah, that's better. Thank you.
Sorry about that. Thanks, man. Yeah, potential performance improvements here. If you have a large index which is 4, which is 4 levels, say, by dividing it into index data sets, you may get each one down to 3 levels. And in that case, you've improved the performance on each of those index data sets. Or it may be that by dividing them up into different multi-data sets, you can now map some of them to different buffer pools in release 14. And so you can get performance improvements by allocating a buffer pool to a particularly highly used part of the index. Ability to quicker recover individual keys in your own data set if you have a problem with a certain key. The minimal QUIESCE options, an index rebuild, just rebuilds the key IDs that need to be rebuilt.
Clyde, not to interrupt you again.
Yep.
But we're having trouble hearing you once again.
Try not to get too close because there seems to be feedback. How's that? There? Can you hear me at all?
Hello?
Clyde, did we lose you?
I'm trying with the mute button. Can you not hear me at all?
Yeah, we can hear you.
I'm not sure where the feedback's coming from. Are we okay to continue?
Yes,
Now we are.
yeah. We can hear you now.
Trying to hold very still. Release 15, just the final bullet here. Release 15 brings us a new option to add and remove keys dynamically, and a bonus of that option is you can dynamically in 15 move a certain key from one index data set to another. So you could now implement multi-dataset indices without an outage to the parent base. So that's a nice bonus in release 15, again a byproduct of multi-dataset indices. Okay, some special things that we do at Customs to provide high availability. And I'll move over these sort of quickly because they're specific to our site. But one of our production systems has to have an outage every 4 weeks because of data requirements, mainly on the application side. But the availability is very important. So what we provide during the 2-hour window every 4 weeks is what they call a prime system. And it's essentially making primary application data available to a alternate multi-user environment while the major environment is undergoing maintenance. So we restore selected data from the system based on the immediately prior DASD split. I talked about the DASD split backups earlier. From that split, once every 4 weeks, we restore targeted databases to another CXX environment. So the data is going to be 24 hours old when we do this window, but it's going to be current enough for the application purposes. The restored data is used by a clone multi-user, and the production regions are just connected to that clone multi-user during the maintenance window. So that prime system runs for 2 hours during the maintenance window, and then at the end of the time, we just switch the CITS regions back to the primary multi-user where the data has been maintained as was desired by the application people. Now, at the moment, we don't do anything with the data on that prime system except back it up and discard it. But with something like the RecID option, the RecID no option on recovery, we could choose to roll that data into the primary, into the main system again if we wish to. That's not a requirement we have right now. This is an example of it's something we worked out in-house to provide data availability during a necessary application window to help our overall data availability. There's a quick chart how it works. Production data, we copy the selected data 24 hours previously. At the start of the window, the production multi-user is up. The CITS regions are connected to it, batch is connected to it, the MQ system, blah, blah, blah. At the start of the window, we simply disconnect the regions from that primary MUF. We connect it to the alternate MUF. The applications run as they were before, and now we're doing our maintenance jobs against the primary or the main data. And that, as I say, goes on for about 2 hours every 4 weeks. And the rest of the time we're running the major system. The other application we have here, which I alluded to, is called the offline reorganization process. This is a non-disruptive reorganization and other maintenance of our large tables. So if we can reorganize or add columns or add keys to a table within the 2-hour window, then we can do that. But for many of our tables, that's not going to work. So we use a CA-provided tool called the LXX Spill Exit, and we use MQ series, and we have a lot of reorganization code. But the idea is that we take a copy of the table and reorganize that on an alternate MUF while adding keys if we want to, while adding data columns if we want to, whatever, we are partitioning it. We've used this to partition tables. When that process is finished, whatever it is, then the LXX records that have been gathered by the spill exit are rolled forward against that copy over the next several weeks even, till that copy is then current. And then when it's current, we have a short outage of the primary system to basically flip that now reorganized, re-architected, partitioned, whatever it is now, we flip that back to the major system with a short outage, and it's current because of the roll forward process. Probably be easy to understand with the diagram. So very simply, here's again the main system. The multi-user has a spill exit connected to it, and that's feeding MQ series queues. We do the QUIESCE, the nightly QUIESCE, or an initial outage window, whichever's easiest. We take a copy of the relevant data. The main system now continues processing, and the spill exit is gathering any log records for that table or those tables. On the other multi-user on the right-hand side, we're using DB utility to reorganize that table, to rebuild its index, to partition it, to add new keys, to add new columns, whatever we need to do. And then that's all done in the alternate multi-user. And then when that's finished, we then connect that MQ series queue up using our assembler roll program to roll forward all those gathered LXX changes into that alternate copy of the data. And then when we finish that, during the next window, we can then move it back to production with a table outage to perform and process the final LXX records, because the table is being updated right till we shut it down. We then just rename the production data sets out of the way, and we rename the rebuilt data sets into the production naming convention, and then we double load the CXX entry from the alternate multi-user into the primary multi-user, because we want the CXX entry to match the data that we've just put back there. So this is the sort of process you could probably emulate in some way using the rec-id equal no forward recovery that's now available in version 14. The batch pipes tool, how are we doing for time? Okay, a little bit. Batch pipes tool is a ZOS subsystem. It's not free, and we only have it installed on some of our LPARS here, but it's very useful, in fact on some of our processors, but it's very useful because it can shorten maintenance times. Basically, in this process, maybe easier if I go to the chart here, the three steps of a standard reorganization, the physical extract, the sort, this is the way we do our reorganizations, physical extract because it's quicker than native, sort into the native key sequence, and then a load job. In a normal utility, there's sequential JCL steps, sequential steps in a job. With batch pipes, they are submitted simultaneously as three separate jobs by specifying certain JCL options. Now the physical extract job runs, and the extract runs simultaneously with the start of the sort. Then when the extract finishes, the sort continues, and now it's running simultaneously with the start of the load. So you're overlapping the three steps of the reorganization process to speed up, to shut the window down from half hour plus half hour plus half hour to, say, 40 minutes plus 40 minutes. And right there, you've saved 10 minutes. You have a look at the JCL. Basically, the extract job contains a subsystem batch pipe 01 with a node name, a dataset name if you like. That dataset name feeds into the sort in of the sort job, and the sort out of the sort job feeds into the input DD of the load job. So the colors here show the concurrently processed datasets, and a key to this process is the datasets are not actually on DASD, they're in memory. So the access to and from them is much quicker than it would be in a sequential sort job, a sequential utility job where you have to write the unloaded records out to some medium. Even if it's just a temporary data set, they still have to go to a medium before they can be read back in. Here the medium is memory all the way through. Of course, you don't get a backup. You can use for security blanket purposes, but it's much quicker. Okay, data access options here. The main one is XCF that we use, and that's the ability to basically run applications on a different LPAR to the multi-user. It means that the CITS regions can be a different LPAR, or a CITS region on one LPAR can connect to multi-users on more than one LPAR. A batch could run on LPAR A while connecting to multi-users on LPAR B and LPAR C, all on the same sysplex using cross-coupling facility capabilities. So the startup params are pretty simple. On the task parameter, you just specify how many XCF, how many remote XCF threads you're going to allow connect to this multi-user, and then the XCF from parameter just provides some of the various metrics for the XCF connectivity, what the LPAR names can be USC anything, USC generic, any limit, job name limits is the second parameter, what the coupling facility control block name is, DBA util, and yes, whether this connection is active or not. So using the dynamic command here, you could turn that XCF capability off dynamically to no if you wanted to stop XCF connections from a certain LPAR. So I mentioned here, I referenced back to what I was talking about the shadow mark earlier, if you have applications that can run on more than one LPAR. A side feature of this is you may want to use RRS, which is the IBM capability to maintain two-phase commit over the two multi-user data sources. If those two multi-users run on different LPARs, you run the CA-provided remote resource manager, RRM, on both LPARs, and that basically extends RRS across the LPAR. So it gives you true two-phase commit capability between those two MUFs on different LPARs. Now that's for batch only. For CICS resources maintain that two-phase commit capability even on different LPARs. So here's a simple architecture, prod MUF1, prod MUF2 on different LPARs. Prod MUF1 has a shadow, critical CICS regions on prod MUF1, CICS regions on prod MUF2, connecting back to prod MUF1, miscellaneous batch on prod MUF1, on LPAR A, connecting to both prod MUFs. You see the capabilities are limitless, and you could even have an architecture where your multi-users run on one LPAR and your CICS runs on another LPAR, and they're not in the same LPAR at all. The capabilities are endless. Speaking hyperbolically. Open systems architecture, data access from open systems. We use the ODB server, ODBC JDB server. And note here that server version 14 supports Java type 4, so you can eliminate the USS proxy. That was a big deal to the person here who maintains our servers. There's a list of the various applications we use. So we have applications that come from a UDB system. We have a Linux-based query application. We have a library service application where web services used to update Datacom data on the mainframe. And we used to use Visual Express to provide ad hoc queries for various categories of users. So it's a wide range of target applications that we use using our ODB server. All our multi-user environments have an ODBC JDB server attached to them. That's another example of making the data available across more platforms to increase its availability. CDC is a sort of another data access capability. If you think about it, the ability to propagate Datacom data to other data managers, like the data warehouse, or for, I guess this is being extended for 24/7 capability, to have a copy of the data you can fail over to if you need to at another site. But basically CDC is making the data available across more than one platform, either across multiple multi-users or across multiple data access methods. CDC Plus, available in version 14, extends the capability of CDC by enabling you to split your CDC replication across more than one database, more than one target database. So it means you can shoot it more effectively. You can have highly valuable data, data requiring to be replicated quickly going through one system, and data required in a more slow manner replicated through another system, and the second one is not interfering with the first one. So CDC Plus in version 14 greatly extended the capability of the flexibility of CDC. And now in version 15, which as I say we don't have in production yet, but we have played with, I mentioned outage-free key manipulation. So in version 15, you can add a new key to a database without any outage. You can delete an unwanted key from a table without any outage. You have the capability to basically turn that key off while maintaining it for an extended period of time to make sure no one's using it. And when you're comfortable, if someone does use it, you can turn it back on immediately. If you find the device is not used, then you can delete it without any outage. And as I mentioned earlier, the ability to move a key from one index data set to another index data set without an outage. Basically, you define it to the new data set, you get it in sync, and then you remove it from the old data set. 24/7 URI reuse, for those of you who may be approaching the, I think it's 4 billion URI count limit on a given area and can't afford the outage to reorganize and reset the URIs. Version 15 gives you the capability to, again, without an outage, start reusing unused URIs in the target area. Faster restart I alluded to, faster shadow failover, and higher log pen, which means more efficient multi-user. I mentioned dynamic or directed extended virtual tables, which probably means the CBS index and the TTM area and index. I mentioned directed extend of the LXX, the ability to make the LXX larger on the fly. And I alluded earlier to the outage-free upgrade path from version 14 to version 15. And basically the key to this is the shadow mark where you have your multi-user running version 14. You can then bring up the shadow actually using version 15 code pointing to a different load library. And then you can fail over from the version 14 to the version 15 multi-user with essentially no outage. So now you're running your version 15 code without an outage. Then you run your dictionary updates, your new dynamic system tables definition, whatever else you need just runs against the dictionary on that 15 MUF, and your upgrade has been maintained to version 15 without an outage. Shadow MUF is key. So just a brief summary, CBP wants and does not always get an always up environment. What that amounts to is a delicate negotiation between the application people who want what they want but have to have their outages as well, and the outages that we feel we need to do data reorganizations where necessary. Less and less of those, but still occasionally required. So they aspire to an always up environment, and the evolving Datacom software makes it more and more possible with every new release. And I think that's about it. So Len, I'm going to pass it back to you, see if you have any questions for me.
Yes, if anybody has any questions, please put them in the Q&A box in the WebEx.
Will I see those, Len?
Yes, you will. So far, there haven't been any that have come in.
I have some questions. I have some questions that came in here I'd like to ask.
All right, put it out.
All right. Clyde, you're getting vague again, so you need to get closer to your speaker. So we talked about high availability and the online utilities. So I was going to ask if there's any, do you have a percentage of how many utilities are now online versus the old offline? Well, we run the online utilities quite regularly. I would say probably 50-50 now. We've probably eliminated 50% of our batch utilities by doing them online more frequently than we were allowed to do in a outage window. Okay, so the follow-on question for that is, what are there performance pros and cons to using the online utilities? I mean, other than obviously it's 24/7, are there performance things that you took a hit on because they run slower, or are you seeing actually better performance? What's your feeling for that?
Our position has been to aspire to maintaining the same performance without having to have the outage window to do the reorganization. So I don't think at any that we've switched that we've had to go back to using utilities, the offline reorganization utilities. We haven't specifically seen any improvements except that we can do them more often. So, for example, a sequential access is degrading. Instead of maybe having to wait 3 weeks to do the offline reorganization, we can do the OLREORG immediately and get the performance back, not better performance, but get it back sooner.
So, I mean, do you have any recommendations for when to use it, like only go to online when you know that you need to have the HA capabilities, or is it just something like you're moving towards online for everything just so you never have to worry about doing the batch stuff?
Yes and no. Basically, we have this window that the application people required. So we feel we might as well take advantage of that for some of our key tables to reorganize them anyway. But when it's all based around the monitoring, Kevin, Rick Brush, looking at all the stats, measuring the sequential access, looking at the index utilization, stuff like that, and targeting utilities based on that. So I would say the key is monitoring the system, and the important point is that you can do what you need to do when you want to instead of having to wait. Okay. Well, I mean, I just wanted to, because it's a good rule of thumb for everybody listening is when to move towards them, because we really see value in it because we don't do the 24/7 window, but for folks that have look for candidates, look for indexes that are filling up or have high delete, add, ones that you rebuild regularly during outages, and try the defrag. See how much it gives you back, see if your performance suffers, and if it doesn't suffer, then you can abandon the regular redux and rebuild. So try it and see. All right, and then a couple more real quick. Obviously, you guys are using zip and everything. Do you have any specific ways you set up the high availability muffs to use zip, or are you just basically running as much zip as you can? 100% across all our big multi-users. Okay. And then my last one was, you mentioned using CDC. I know you guys have the special CDC implementation with the CDC secondary muff and whatever, but what's the performance overhead of using a CDC versus like the LXX Spill? Well, the CDC, the advantage of that is that it's supported by external software packages, so we don't have to write any code of our own. I mean, CDC is the supported technology. You know, I love the LXX Spill Exit, and it saved our butt, assuredly, but I would not recommend anyone goes that way now. There's a lot of coding for it. CDC is efficient for our purpose. It's supported by external software packages, and that would be the way to go in future for people who are looking to replicate. I've got to drop off in about 2 minutes. Okay. So, all right. So I'll shut up and I'll let everybody else ask questions. But I just was interested. Sorry. Just one quick point there. We use the secondary muff CDC for big systems for which we decided the LXX impact would have been too great in doing CDC in the one muff. That is one environment. The other lesser production systems, we have a local CDC because the LXX impact is not bad enough to be noticed. Okay, and I've got to go because I'm losing my conference room. I guess there's no more questions, right, Len? Yeah, no, there aren't any questions in the WebEx. Okay, so thank you for your time, everybody. Appreciate it, and back to work. Thank you, Clyde.
Thank you so much, Clyde.
Hello.